Okay, we're here at the top of page 2 of the notes for section 1.3. Got some more examples to go through here, and we are looking at the instructions say to graph each real number on a number line. And so to conserve space a little bit here, I will go ahead and draw one number line, and we'll plot all these on. Now hopefully this is a review as well. The basics of the number line is it's a way of visually organizing and keeping the numbers in order. It's a great way to visualize to see where those in-between numbers, those rationals, will fall, as well as the irrationals. Although we can approximate where they land, we can't put an exact point as we would zoom in on the line because they don't have a finished decimal. That's why they're called irrational. But as you go to the left, it's negative. As you go to the right, the number line is positive. I have always maintained the habit of putting 0 as a reference, even if it's not a point that you are putting on the that you're plotting on the number line. Equal spacing will help us out here as we keep going. See if I can do this. I'm not eyeballing it perfectly here, but so we've got 1, 2, 3, 4, 5, and it keeps going. -1, -2, -3. Sorry, I don't mean that other pen to be in the way. -5, and keep that going. The first one, -2, we'll use that as point A. So -2 is 2 to the left of 0, so here is our A value. 7/3, you have a lot of choices. You can convert to a mixed number or a decimal and then plot it. Okay. You could also, well, we'll get to that in a minute. You could convert it to a mixed number, okay, and we'll call this point B on the graph here. So you can convert it to a mixed number. 3 goes into 7 2 times with 1 left over, so this is 2 1/3. As a decimal, you divide 3 into 7. It goes 2.3333. The 3 is repeated. So we need to go 1, 2, and about 1/3. Let's estimate that, or it's exactly 1/3, so we need to estimate exactly where, or about where that is on the paper here. This is point B. And then what I started to say a minute ago is what you also could do is just think of it in terms of this improper fraction. Again, that doesn't mean wrong, it just means top heavy here. So think of it in terms of counting out 7 1/3. So if you imagine each of these individual units then being broken up into thirds, you would count from 0 7 of them. 1, 2, 3, 4, 5, 6, 7, and you'd still land at that same point. So that's another way to do it. So I'll write that over here, up here, as out of the way, or count 7/3 from 0. Okay, so that's a third way to do it. And then this last one, let's use green for this one. We'll call this point C. This one is already at a decimal. 0.4 would mean 4/10. Okay, so this is 4. 0.4 is 4/10. So imagine that the space between 3 and 4 has been divided up into 10 chunks here. So it's not quite at the half. Let's see if I can fit. Yeah, that's about, I think that's, they're not exactly spaced, but there's 10 little spaces now in between 3 and 4, and we'll go at, oh, I'm sorry, negative. Cut that in half. 1, 2, 3, 4. Okay, and so -3.4. Okay, you always continue on because anything to the right would be in the -2 area. So as you go left, you want to, the numbers get bigger, let's put that in quotes, as you go to the left. So this is point C. And when I say bigger, I just mean, 4 would have been further to the left than -3.3. And that's further to the left than -3.2. in terms of value, less is on the left and right, positive or greater than is on the right. And I'll just make one more note here. Always include 0 for reference. Okay. All right. Now we get to express each rational number as a decimal, and what we're really talking about is we're converting fractions. Express each rational number as a decimal, converting fractions to decimals. So there are a couple different ways to do this, but I think the one way that guarantees you a path to the answer every time is to do this, is to divide the top number divided by the bottom number. Officially, that's the numerator divided by the denominator. Okay, which means that when you're actually setting it up, you would put the bottom number on the outside of the division and the top number on the inside of the division. That's what divided by means. You're seeing how many times that bottom number will go into the top number. And then you do long division. Now the reason why you're seeing me do this is because this first exam is no calculator. Okay, so we need to know how to do this. We need to be able to refresh our skills on long division here. So notice this first one we're dealing with is a negative rational number. That doesn't change how we do it. We're still going to divide the top divided by the bottom. And I just want to start planting a good seed that's going to really help you out here. Anytime you see a negative in front of a number, I want you to start thinking about that as if it were -1 times that number. Deal with what you need to deal with the number, and then just multiply it by the -1 at the end. This will save you a lot of heartache if you can start grasping this concept as we move towards 65 even. Okay, so we're going to divide 4 into 1. 4 is on the outside, put 1 here. 4 can't go into 1 evenly, that's why it was a fraction in the first place. So we add the decimal, which means we're going to put a decimal up here, and we add a place value in the tenths with using a 0. 4 can't go into 1, so we put that 0 here. That helps not lose track of that decimal where it is. So then now we move over one place. How many times does 4 go into 10? Ignore the decimal. We're looking for that both places here. How far can 4 go into a value of 10? Well, it can go in 2 times, and 2 times 4 is 8. Subtract those. 10 minus 8 is 2. Then we're not done until you get a value of 0 or you start to repeat endlessly. So we add another 0, bring it down, and we ask ourselves how many times this 4 goes into 20. It goes in 5 times, and this time it is exact. 5 times 4 is 20. So now no remainder, we're done here. That's our decimal, 0.25. But remember, it started out as -1 times 1, or -1/4. So we have figured out what the 1/4 represents. Now we reapply that negative, or think of it in terms of multiplying by the negative. So -0.25 is our final answer. Let's look at number 28. Some of you may have looked at 1/4 and been able to convert it in your head. And I would hope most of you would recognize that. Oh, 1/4, it's like a quarter of a dollar. Quarters are worth 25 cents. You should be able to connect those to real life stuff, okay? However, I'll do this on a lot of the easy problems because I know that these problems are going to get harder. The cool thing is, if you know how to do the steps are the same for whether they're easy or harder. So if you practice the steps while the problems are easy and you know what the answer, you know what to expect as your answer, you can start getting really confident in your steps and then apply the steps with confidence to when the problems get harder. Okay? 3/11 is not really something that's kind of floating around in our brains here. So it's positive, so we're just going to jump right into the division here. We're going to be dividing 11 into 3. And it doesn't go into 3, so we need to give it some placeholders here to start creating the decimal. And we'll put that it goes in 0 times into that. And then we think, how many times does 11 go into 30? And twice, without going over, kind of like the Price is Right. Get as close as you can without going over. 2 times 11, 22. Subtract that. 8 is left over. So we need another placeholder to come down here. And then how many times does 11 go into 80? It goes in 7 times. 7 times 11 is 77. Subtract that. We're left with 3. Another placeholder. Let's extend that line out a little bit. 0. Bring that down. And just like we were a few minutes ago, we're going to be putting 11 into 30. Okay, and numbers don't change. The same process is going to happen. You put 11 into 30, you're going to get a 2 here. 2 times 11 is 22. You'll get 8 left over. Bring down a 0. 11 goes into 87 times. You'll have 7 times. You'll have 3 left over. You're going to get this 30, 80, 30, 80 thing happening, which means that your 27, 27, 27 is going to start to repeat. And so you can write that as 0.2727 with the dots, although to conserve space and to just make sure we're ultra clear about what the answer is, the mathematical symbol you can use is to write the decimal, include all the digits that repeat, and then draw a straight bar over the top, and that indicates that those particular digits continue to repeat forever. They do not stop. Okay? All right, so copy what you've seen. Note any questions that you can bring those to class or to your help resource if it's several days before the next class. And then pause the video and try number 24 on your own. Okay, and when you do get a chance to try number 24, here comes the answer, 0.15 or 15 hundredths. And just as a reminder, once again, there's no calculators on exam 1, so you will need to know how to do this type of conversion and using long division by hand. Okay, we'll see you at the bottom of the page.